Seznam.cz is a local market leader ever since, because Seznam.cz it's one of those companies who is crazy enough to compete with Google on local market. And now we get to the core of this talk, how we created the VHR 3D map of Czech Republic. The mapping process can be divided to 4 subtasks: data acquisition, data processing, data management and fusion, and data distribution. So firstly, briefly about data acquisition. Data acquisition is handled for us by third-party partner, and data are delivered in blocks in various time, and it's a continuous process. As you can see on this map, the whole country is divided into blocks, and I'm sorry. Yeah, we are back. So the whole country is divided into blocks, and the darker part it's areas with better GSD pictures imagery. Okay, let's see slightly into processing. The processing is done with our fully automatic photogrammetric system. System creates all output data sets in a single unified process. So we have a digital surface model and orthophoto and true 3D map on output. The only manual input is a definition of ground control points, of which we needed a lot. The process consists of input quality control, GCP definition, photogrammetric system initialization, processing, output quality control, and packaging for delivery. Of course, we didn't process all area together. We have split the whole Czech Republic to 350 square parts called targets. And one target has about 225 square kilometers. Targets were processed and delivered gradually. And at this diagram on slide, you can see the mapped area division with the status report information of each target. But the important part I want to talk about are the last 2 steps. These steps we have covered with our open source VTS 3D geospatial software stack, which is the second project I talked about in the beginning of this talk. And let's talk about VTS briefly. VTS is an integrated platform for 3D map application development, and it's a virtual landscape streaming and rendering engine. And as I mentioned before, it's fully open sourced under BSD 2 Close license. There was more talks about VTS yesterday, and today will be another 2 just after this presentation. So feel welcome to stay and listen my colleagues talk about VTS closely. The strongest point of VTS are data scalability. Data scalability. You can fuse together countless amount of 3D and 2.5D data. High performance streaming servers with bandwidth optimized dynamic triangle irregular mesh, orthophoto generation and static tile streaming. And VTS provides lightweight and fast client libraries for web and desktop. Okay, now let's talk about the data management. At the end, we are handling more than 10 terabytes of data. And the result map consists of many data sets. So there is a global context, which is a global DEM with a satellite imagery. There are multiple true 3D models with various GSD. As I mentioned before, there are extra VLAN areas with 12.5 centimeter per pixel, and major cities with 10 centimeter per pixel. And of course, there are vector data with labels and features. VTS is able to fuse those data sets together very smoothly. And the process of fusion must be re-entrant and of course low cost, because it's happening a lot. More about fusion you will hear from my colleague Ladislav in following talk. So let's move on. As I mentioned before, the data from photogrammetric software comes in targets, and on production servers are data joined to logical groups like cities and landmarks or extra VLAN. In VTS map configuration are those logical groups referenced as one data set. It's very helpful for quality of streaming and rendering the resulting map. And the last part of mapping process is distribution. To provide the best user experience which is desired, we need to have in mind basic rules of what is important for streaming. And streaming needs as few data as possible. So in VTS we optimized streaming by advanced mesh compression and by texture packing. The user experience is crucial to speed up the first load time. So VTS help us there with virtual surfaces. It reduces amount of loaded meta tiles and so on. And of course, the loading policies needs to be also optimized. In production, there is a robust content delivery network which allows us to keep more often used data as close to user as possible. So there are caching CDN edges, and the request on the VT streaming server are passed in very low frequency. Okay, so that's basically all about VTS. And VHR 3D photogrammetric map of Czech Republic, and please let me show you the brief tour around the portal of Mapit.cz. So in here you can see the portal. It's a classical map applications. A map application consists of a whole world. There is orthophoto satellite imagery, and in Czech Republic, we have better data. But what is what is important in this talk is this 3D view button. When it's activated, the portal is switched to 3D view. As you can see, that it's not more no more projected map, but it's a globe with the whole world context. But again, in Czech Republic, you can see that there are better data. There are the true 3D model of whole Czech Republic, and we are zooming to some major city to see this in action. Yeah, here you can see the high resolution VHR resolution map of Prague. And the last thing I want to show you is the nice and smooth boundary between two very different data sets. And it's thing which will be covered with my colleague Ladislav Horký in the next talk. So that's all from me, and now we may open the floor for questions.
Thank you very much, Thomas. Thank you very much, Thomas. Nice presentation.
Thank you.
Do you have any question about this presentation now? No, it's clear? Okay, so we finish here this presentation, and we are, thank you very much again.
Thank you.
And we are going to wait about 1-2 minutes if anybody wants to come from the other room.